So this is the production system particularly of our well, okay, which starts with the reservoir. This diagram I have drawn in the classroom also many times. So you have the reservoir, okay, from here. So the reservoir gives you some fluids or some oil and gas to the well bore, this here, this particular place, this one, okay. Now what will happen? Whatever fluids are there, they will travel through this particular casing to the tubing, from the tubing to the wellhead, through the flow lines to the separator, until it reaches to the storage units or storage places, okay. Now there are a lot of delta P or the pressure losses or the differential pressures, okay. Everything is same. Delta P, which is also known as differential pressure, pressure difference, or drawdown, okay. So these are 3 Ds. They can be this, they are the same, okay. There are a lot of pressure differences that will be encountered in the well, okay. So there will be some pressure losses which will happen in the reservoir, because what is happening? Your fluid is flowing from somewhere from here, and it is here, it is at the same pressures, okay, because the overburden is same. But as soon as it is coming to the well bore location, what is happening? This pressure is encountered with a lower pressure here. So there is some pressure loss that is happening over here, okay. So delta P reservoir. Now since your well is flowing from bottom hole to the surface, there are some pressure losses that are happening in the tubing itself. So delta P tubing. There are some pressures which are losing in the flow line, okay. You have seen that is because of the hydrostatic pressure, because of the gas velocities and all those different things, viscosities and all those things, okay. Now here is the flow line. So this is our total production system, which we will talk about, and we'll see how do we monitor this production system throughout the life of the well, so that it is producing in the best way possible, okay. Now because we are talking about 2 different entities over here, which is the well, which is producing from reservoir to the bottom hole, okay. This is the first entity, and the second one is the from the bottom hole to the surface, okay. So we have to keep in mind or keep in moderation these 2 particular flows, one from the bottom hole to the well bore, from the reservoir to the well bore, and second from the well bore to the surface, okay. Now you will understand what I mean to say is, let me show you through on the whiteboard. So what do you have is, you have some flow rate Q and some pressure delta P, okay. So you have 2 graphs. So you have a flow rate and a delta P. Now this graph particularly corresponds to the flow from the reservoir to the bottom hole, okay. मतलब यहाँ से यहाँ तक जब आएगा, this is PR and this is PWF, okay. So this graph will corresponds to the flow from PR to PWF only, okay. This second one, this graph will correspond from PWF to the TH, tubing head, okay. So you have 2 graphs. One is from the bottom hole or from the reservoir to the bottom hole, and the second one is from the bottom hole to this one, okay. Now this graph can be like this, something like this, okay, and this graph can be something like this. What do we do is, we make a graph where we interpolate both of them, these both graphs. So if I have this one and if I have this one, so I check the places where both of these graphs are meeting me, okay. So this is flow rate and this is pressure, okay. So I get that point where both of these graphs are meeting, okay, this point or this point. So these points I need to find out. What is this point? This point is some flow. Okay, maybe Q0 we can take this one, and this pressure. Okay, so this pressure we may take as P0. Okay, so now what do we see is, we see one point where both this inflow and the outflow is getting same. Okay, so now if I talk to you about, or if I talk about this particular reservoir, so what will happen? There will be one certain pressure and one certain flow rate at which we can flow from our reservoir to our bottom hole. Okay, and second can be one flow rate and one pressure at which we are flowing through from bottom hole to the top. Okay, so you will get two different graphs. Is particular area ka ek graph, this particular area second graph. What you're going to do is you're going to interpolate both these graphs, so that what you're going to do is, even I think here also I can draw. So what you can do is, you can interpolate both these graphs and check where these graphs are coming together. Okay, at that flow rate, if you flow your well, yahan se on the surface, if at that flow rate you flow your wells, what will happen? Your well will give you its maximum productivity. Okay, so what will happen? Because you are producing or flowing at the correct pressures and temperatures, or at the correct pressures and flow rates, sorry, not the temperatures, pressures and flow rates, your well will be flowing throughout its life to a large extent. बहुत लंबे time तक वो well चलेगा. ठीक है? So this is what we are going to study, and how we are going to draw those graphs and everything, that's we are going to see. So you see the production system analysis, if we talk about, it is for analyzing the production system to understand the hydrocarbon phase behavior, which is very, very important. Because what we are doing is, if I see this pressure versus temperature, and this is my phase diagram. Okay, my phase diagram of a multi-phase system. Okay, if it is a single phase system, it goes something like this. But if it is a multi-phase system, there is an envelope that is created, which has a bubble point on one side, dew point on the other side, dew point on the other side, and then you have your different phases inside the bubble, inside this envelope. Okay, outside this envelope only liquid phase is present, outside this envelope, this side only gas phase exists, and both multi-phase exist inside this envelope. Okay, now if I talk about this particular condition, what happens? Our reservoir or our fluid is somewhere here at the reservoir condition at A point. Okay, now from A, it is coming to the C. You see pressure over here, it is very high. Now what is happening? Slowly the pressure is decreasing as your fluid is coming to the wellbore. So this is A, where the pressure is PR and TR, which is reservoir pressure and reservoir temperature. It is coming to B point, which is the wellbore. Okay, now at the wellbore, what is there? PWF and TWF. So what are you doing? You are coming. Okay, one second. So what you're doing? From your reservoir here, this is your reservoir condition, this one. Okay, from your reservoir, you are coming to your wellbore here. Okay, everybody is understanding what I'm drawing? Please say yes or no. Please say yes or no.
Yes, ma'am.
Yes, ma'am.
You are understanding, right? Because we are what we are seeing. We are seeing from the wellbore, from the reservoir into the wellbore it is coming, and from here to here. Okay, so this in this graph I'm particularly showing you. All right. So you see what is happening. From here it is coming to TWF. Okay, from your reservoir it is coming to your bottom hole or the wellbore. All right, so this is the condition, B condition. So this one, let me show you by a different color. This one is A. Okay, and this one is B. So on a graph, on a phase envelope, if you see it, it is somewhere here and it is somewhere here. Now from here, it is coming to the surface. There is a drastic change in the pressure, and because the pressures are changing, there is sudden evolving or the sudden burst of bubbles of gases that comes from this one. Okay. So you see over here, what is happening from here? This one is this C is somewhere when it will cut the bubble point. When it will cut the bubble point, then the bubbles will get evolved from here. So जब हमने मल्टीफेज फ्लो में पढ़ा था ना कि फर्स्ट बबल फेज होता है, फिर उसके बाद तो दिस इज द फर्स्ट वन व्हिच कम्स, बबल फेज it will come. Okay, so you see over here, this is somewhere the point C. Yes. Now what will happen? It will further, as you are coming to the surface here. Okay, as you're coming to the surface, the pressure is slowly decreasing unless it is reaching the atmospheric pressure or the surface pressure. Okay, now it is slowly decreasing. It goes through various stages, C, D, E, and then it comes to the F. Okay, so this is the C, this is somewhere D, E, and it comes to the F, which is the separator. So somewhere here, there will be a separator on the surface. So what we have done is we have crossed everything. Okay, from here we have crossed the wellhead, we have crossed the flow lines, and we have just come to the separator. So this is the F condition. So what is happening? Your well is once again flowing from the bottom hole or from the reservoir to the bottom hole, through the tubing, through the flow lines, wellhead, surface, to the flow, to the separator. Okay. So what do? We need to analyze or understand phase changes when hydrocarbon reservoir fluids move from the reservoir environment, which is this one, at high temperature and pressure, to the surface conditions, which are cooler and the pressures are low. Okay. So we need to understand how the phases are changing. We need to understand how do we cope up with those things, and how do we understand what flow rates do we require. कि किस pressure